For problem 7, we want to now try to find the antiderivatives using recognition from the table we just completed. So the derivative of e to the x is e to the x. The 2 stays out front, so it's just 2e to the x. The 3 stays out front, and we saw that the antiderivative of secant squared is tangent x. And then we add on our plus c. For part B, it's going to help if we rewrite this problem before we try to antidifferentiate. So this is the same thing as the integral of pi x to the negative 1/2 plus 17 x to the negative 4/3 minus 1/5 times 1 over square root of 1 minus x squared dx. So now I can use a power rule for these two terms, and this is a known derivative. So if we apply the power rule, it's pi x to the positive 1/2 dividing by 2 is the same thing as dividing by 1/2 is the same thing as multiplying by 2 plus x, when we add 1, I get negative 1/3. And if I divide by negative 1/3, it's the same thing as multiplying by negative 3. And so 17 times negative 3 is negative 51. Then I have negative 1/5, and the antiderivative of this is arc sine. Alternatively, I could also get x, 2x, or 2 pi x, excuse me, to the 1/2 minus 51x to the negative 1/3 plus 1/5 arc cosine x plus c. So we actually had two options here, so either one of these would be an acceptable solution. 2 to the t is the same format as a to the x, so the antiderivative of this is 2 to the t over ln of 2. And then this is negative sine, so this is plus 3 cosine of t plus c. For the next problem, we can't undo the product rule. So what we have to do is distribute our x across. So when I multiply 7 by x, I get 7x, but when I multiply 1 over x squared, the x cancels, so now I want to antidifferentiate this. So this is 7x squared over 2 minus the natural log of the absolute value of x plus c. Part E, I want to rewrite a little bit before I start. So e to the 3x we can't really do much with, but this is the same thing as 8x to the negative 9/5. So now, in order to do this one, I don't exactly know what the antiderivative of e to the x is, or e to the 3x, excuse me, but I know it's some form of e to the 3x, so I'm just going to leave that there for now. This term I can definitely do with a power rule. So x to the negative 9/5, when you add 1, it becomes negative 4/5. And so dividing by negative 4/5 is the same thing as multiplying by negative 5/4. So 5 times 8 is 40 over 4, and it becomes negative. Now I need to verify that this is right. So if I take the derivative of e to the 3x, what I actually get is 3e to the 3x, because there's a chain rule involved here. So if I compare this term to my term right here, well, I need to put a constant out front in such a way that when I take the derivative, it reduces back down to e to the 3x. So since the derivative is going to bring a 3 out front, I actually want to multiply this by 1/3. So now, if I check my derivative, if I take the derivative of my answer, I have 1/3 e to the 3x times 3 minus 40 over 4 times negative 4/5 x to the negative 9/5. So if I reduce this down, you can see the 3's cancel here, and I get e to the 3x. Here, my negative times my negative makes it a positive. My 4's cancel, and 40 divided by 5 is in fact 8. So I can always verify my answers by just taking the derivative of the result, and I should get exactly what I started with in the original problem.